Work in HCI and AI-based explanation systems has uncovered an interesting contradiction. People prefer and learn best from why explanations, but expert esports commentators primarily answer what questions when explaining complex behavior in real-time strategy games. In this work, we find this is likely because why explanations are cognitively demanding to process during a live match. Our story begins with explainable AI, which is the ability for artificial intelligence systems to explain behavior to external observers. To curate explanation strategies for explainable AI systems, recent work by Dodge and colleagues at SIGCHI studied how expert esports commentators, called shoutcasters, forage for information, synthesize observations, and present explanations to their audience during real-time strategy game broadcasts. They began their inquiry with existing work on intelligibility types. These types categorize approaches to explaining the operation of complex systems based on different types of questions an end user might ask. Foundational work on intelligibility types show that users learn best from and prefer why explanations. However, Dodge and colleagues find that human shoutcasters overwhelmingly answer what questions and why type explanations are their least common. So, why is this the case? There are several possible answers. First, it could be that well-informed audiences who tune into esports events don't need why explanations because they can already predict expert-level play. Second, it could be that why explanations are beneficial, but require too many cognitive resources for the audience to process in the context of a live match. Finally, it could be that audiences can process why explanations, but they are underserved by human shoutcasters who do not have the resources to generate why explanations in real time. In this work, we empirically explore these possibilities and find evidence that supports possibility 2, that why answers are cognitively demanding for even expert audiences to process during a live match. For the experiment, we built an online platform to stream a professional Dota 2 match to our study participants. Dota 2 is a popular online multiplayer strategy game with a large professional player base. Participants access our online platform through their web browser. To test our 3 possibilities, we split our participants into 3 groups. Group 1 watched a 10-minute recording of a professional Dota 2 match. Group 2 watched the same 10-minute recording, but were also presented with a map of the Dota 2 play area. On this map, icons appear during 12 important events that happen during the clip. When an icon is clicked, a simple what style explanation of a recent event is given in text. This explanation simply summarizes the event, providing no further analysis. Group 3 also receives the minimap and icons, but their text contains specially curated why explanations. To generate why explanations, we devised a curation task and recruited 3 expert Dota 2 players. Dota 2 rates skill and matches players together based on a metric called MMR, which is similar to the ELO system used to rate chess players. Here is a distribution of nearly 4 million players across MMR tiers in Season 4 of Dota 2. The average MMR of our 3 experts was 6,540, which places them in the Immortal tier. This tier comprises the top 0.78% of Dota 2 players. We told our experts that a why explanation connects 2 or more actions or states in order to explain a causal sequence. We then asked them to create why explanations for each of our 12 events. After collecting responses, we coded each sentence and accepted full responses with the most common features between our experts. To collect participants, we used the prolific crowdsourcing platform. Our participants needed 3 qualities to be considered for our study: recent experience playing Dota 2, English proficiency, and a desktop or laptop computer to use the experiment platform. After finishing their session, participants fill out a series of questionnaires. First, they are asked to rate the mental effort they expended while watching the match on a 9-point scale. Second, we had a simple quality check about what teams participated in the match and how long the video was. Finally, we asked each participant to answer 7 multiple choice questions about events in the video. Each one is a what question about gameplay events, and the answer is always a particular player. The choice options for each question are the list of 10 players that participated in the match. Given our 3 possibilities and 3 groups, we expect to observe one of 3 outcomes. If possibility 1 is the case, we expect either no difference in recall or higher performance in group 1. This would be because explanations do not help or possibly even distract informed viewers. If explanations distract viewers, we would expect higher reports of cognitive effort from groups 2 and 3. If possibility 2 is the case, we expect group 2 to outperform the other 2 groups on the recall task. We also expect higher cognitive effort from group 3. If viewers benefit from explanations, but why explanations are harder to process in real time, then we expect the group receiving what explanations to score the highest, and the group with why explanations would report higher cognitive load. Finally, if possibility 3 is the case, we expect group 3 to outperform the other 2 groups on the recall task. If this is the case, viewers are being underserved by shoutcasters and can benefit from real-time why explanations. First, we analyzed the recall scores. We performed a one-way between subjects ANOVA and found a significant effect for the 3 conditions. A post hoc test showed that the what explanation group performed significantly higher than the no explanation group. The why explanation group lay somewhere in between, neither being significantly higher than the no explanation group or being significantly lower than the what explanation group. Next, we analyzed the cognitive effort reports. We performed a second one-way between subjects ANOVA and found a significant effect for the 3 conditions. A post hoc test showed that the why explanation group reported significantly higher effort than the no explanation group. The what explanation group lay somewhere in between, neither being significantly higher than the no explanation group or significantly lower than the why explanation group. Together, these results support possibility 2, that explanations are beneficial to informed audiences, but processing why explanations in real time is a difficult task. The most exciting aspect of this work is that it opens up new possibilities for AI systems that dynamically explain complex events. This study was undertaken by the Weaver Project, whose goal is to provide automated, personalized stories to audiences during a live esports match. The results of this study are exciting because they show that by simply directing a viewer's attention to important events and providing short, natural language summaries of game events, we can add value to a viewer's experience. Future work could test this effect in a large-scale production environment, or test other aspects of audience psychology for use in automated, real-time explanation generation. My name is Justus Robertson, and I want to thank you for attending from myself, my colleagues at the University of York, and at Weaver.